Hi, welcome to our math. Today I'm doing a series of videos on finding the inverse to a matrix. And this is kind of one of the applications we can utilize the inverse matrix for. So it first says, write the system as an equation of matrices. What that means is we start by writing the coefficients. So the 4, the -7, the 5, the -9. This is what we're used to when doing kind of elimination methods with matrices. But then what we're going to do is we're going to write another matrix with the x and y. If you think about how multiplying matrices work, this translates to 4 times x plus -7 times y, 4x minus 7y. 5x plus -9 times y, 5x minus 9y. And we can say that this equals 8 and 11. If we do the same thing with the next one, we get 4 -7, 5 -9 times xy equals -3, 7. And if we do this last one, we have 4 -7, 5 -9 times xy equals 0, 20. I want you to notice that all three of our initial matrices are the same 4 numbers. So the theory behind what we're doing, we're going to call this matrix A, this X, and this B. Now, this is the same A, this is the same X, but we'll call this the first B, the second B, and this is A and X, and the third B. And the theory behind what we're doing is we're trying to say if A times X equals B, and we multiply both sides by the inverse, because you can't really divide by matrices, I get A inverse times AX equals A inverse times B1. Now, if you've done other multiplication with matrices, you know that multiplication is order specific. So if I multiply to the left on the left-hand side, I have to multiply to the left on the right-hand side. Multiplication cannot be any direction. This right here is the identity matrix, and anything times 1 is itself, which means this becomes x equals the inverse of A times whichever B we want. So if we know the inverse of A, we can multiply to each of these 3 and get all of the answers really quickly. Okay, so there's the theory. So what do we want to do next? We want to find the inverse of A. So the way I'm going to do that is I'm going to start by rewriting A down, the 4, -7, 5, -9. I'm going to put a line and an identity matrix. If I calculate the left-hand side to be an identity matrix, the right-hand side becomes the inverse. So I'm going to pivot on that 4. I'm going to say 5 times row 1 minus 4 times row 2. 5 times row 1 is 20, -35, 5, 0. And 4 times row 2 is -20, +36, 0, -4. So we get a 0, 1, 5, -4, and that's super duper handy. Okay, so we're going to come up here with this. We didn't change the first row. 4, -7, 1, 0, 0, 1, 5, -4. We pivot on the 1. So we just say row 1 plus 7 times row 2. All right. So row 1 is 4, -7, 1, 0. And 7 times row 2 is 0, 7, 35, -28. And when we add down, we get 4, 0, 36, -28, and we will divide through by 4. So our new row 1 is 1, 0, 9, -7. Row 2 is 0, 1, 5, -4, which means the inverse of A is 9, -7, 5, -4. Okay, so now we have our inverse. Now, what we figured out in our theory is if we multiply the inverse to our answers, we should get the solution to the system. So that means for B1, if we take 9, -7, 5, -4, and multiply that to B1, which is 8, 11, we get, remember, you go across and down, so 9 times 8 plus -7 times 11, then 5 times 8 plus -4 times 11, and this is going to equal a -5 and a -4, which means the answer to that system is -5, -4. The solution to this system right here is -5, -4. Now you might be thinking that is a lot of work. Now this part in here was theory, but you might be thinking that's a lot of work to solve the system. But we can now solve these two systems as well. All we need to do is put our inverse matrix times our next set of solutions, -3, 7, and multiply. 9 times -3 plus -7 times 7, 5 times -3 plus -4 times 7. And when we multiply and add these, we get -76, -43. So our solution is -76, -43 as an ordered pair. So now we've solved two of them, and to figure out the third one, we just do one more quick multiplication, especially with that 0. So we have 9 times 0 plus -7 times 20. We have 5 times 0 plus -4 times 20. So this is -140. Oh, this should be a -20. Negative, negative, positive. And then a positive 80. So the solution is 140, 80. So now we have the solution to all of these. We come back to our original equations. This first one is -5, -4. Second one is -76, -43. And this last one is 140, 80. And just like that, we have solved 3 systems of equations. All right, I hope you've enjoyed this video. Please subscribe to my YouTube channel, like my Facebook page, and I will see you on the next video. Thanks.